So just to get started here, we got some words for estimation, right? Like more, less, a little. Um, all of these are kind of, I don't know, counterintuitive to math, right? They don't really mean a lot to mathematics because they're 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 not exact, and math by itself is supposed to be exact. So if you said I have a lot of bacon, it's like, well, how much bacon is that? I mean, to some people that's one piece. To others, it's a pound. You just never know, right? So mathematics allows us to be more specific than just using estimations or this type of terminology like we see here. So yeah, we don't like to use estimation. I mean, we are going to use rounding in math, but estimations are good kind of for like split decision kind of stuff. But generally speaking, we want more exactness when we look at the math. Now, keep in mind that I am recommending right now that for some of our basic facts, at least with the four basic operations, you're going to want to memorize that stuff. All right. So that in that way, if we look at one of the basic calculations like 5 plus 4, you would know right away that it equals 9. Almost like you know right now that 1 plus 1 is 2, right? It's like you don't really have to count on your fingers, oh, 1 and 1 is 2, most of the time. Now, until we get to that point, we may need some more concrete ways to use, to count, okay? Such as using fingers. Now, as adults, sometimes when we use our fingers for counting or doing some math, it's like, dude, if I use my fingers, I'm going to look like a fool. Please don't. Don't feel like you're going to look like a fool. Just do it, okay? Because I do it, by the way. I know we're not in person, but I do it when I use my calculations. Sometimes, well, a lot of the times I use my fingers kind of keep track of where I am or for counting, okay? So like 5 plus 4, you could say, well, I got 5 fingers, and then I can count another 4 fingers, and boom, you see you got 9 fingers held up, and so the answer is 9, okay? Again, until you get those memorized, you may have to use your fingers for that, but we do want you to get to the point that you have all of that stuff memorized, okay? At least for the first 10 values. That would include 0, really. But if you can go past it up to like the 12s and into the 20s, okay, that's even better, all right? So again, you would start with like 0 plus 0 all the way up to 9 plus 9. Boom. We want you to know at least that much. Have it memorized. For the 4 basic operations, we'll start with addition and subtraction, all right? That's our basic arithmetic right there. Now, just so we understand a little bit about the math, just the number system that we use in mathematics, okay? So we have digits to represent value. And sometimes, like, these are individual single digits, right? 1 through 9. But it is possible to combine digits together, like this one. This one reads, it's not 1, 6, although those are the 2 digits. It's 16, right? And that's the beauty of our number system, is that we can represent bigger numbers with the same 9 values. So it's almost like reading, where you're just trying to memorize the sounds of those first, 24 letters. And then after that, then you can push them together to make bigger words, right? So it works the same way with numbers. And they're hieroglyphic in nature, right? So they're symbolic, meaning if I say 3, you would know that I mean a quantity value, right? Like if I said 3 horses, okay, in your mind, you should be able to at least picture what 3 horses would be, instead of there being some confusion like, what does 3 mean? You know, like if you have that much down, then we're at least ready to start this class, okay? And it should work with bigger numbers, right? Like 233 right here. If I said you had $233, you should know about what that means, right? Not necessarily in terms of purchasing power, just like how many $1 bills would that be, okay? And yeah, I know the answer is 233, but again, quantity, what does that mean, all right? So if you know that stuff, that's good. Now, the other thing about our number system is that, like if you relate it to other number systems like the Roman numerals, right? If I said, let's take 13 like this, and let's add it to 5, okay? And if you use the same number system that we do, we would set it up like this and would say, I don't really know what the crap to do. Okay, oh, okay, well, you can just kind of squish the V in there and you'd have it down. But then it's like, well, okay, if I add another 1 there, then what do I do? Oh, okay, then you're looking at switching an I and a V around or something like, some kind of garbage like that. See how that, it's not very convenient. Could you do it? Yes, you could. But it's not very convenient. So that's the beauty, that's the genius of our number system, is it places all the numbers in their place values, which is our first lesson here. So if you look at digits, like what was one of that, 233, right? So if we push numbers together like this, each number is representing a specific place value. So even though we have 2 numbers, even the number that repeats right here, because of where it's placed in the number, the digit 3 may mean something different based on its placement. So that's our place value system, which, and math people love this when it first came out, which, by the way, it's based on the Arabic system. It allowed math people to do calculations a lot faster than they would with Roman numerals like we've seen, okay? So if we can get this place value stuff down, then some of the other calculations we do, if they're not faster, they should at least make more sense. So there's 2 types of numbers we're looking at here. We got natural numbers and whole numbers. Natural numbers occur in nature. They're just counting numbers. Notice there's no fractions or decimals though, right? So it's 1, 2, 3, 4, 5. 3 dots means that it continues in that pattern forever and ever and ever, okay? So, you know, it goes up to the billions and trillions and so forth. Now notice as well, all these natural numbers are included in the list of whole numbers. The only difference is the number 0, because the number 0, mathematically speaking, is not considered natural because it means you have nothing, which is unnatural. So 0 is considered a whole number. Now, we may not be using this terminology very often. I may use it from time to time, specifically whole numbers. But really, whole numbers and natural numbers means we don't have any decimals or fractions. Oh, here's our objectives. Yeah, we've got to be able to name specific place values for whole numbers. Should be able to write whole numbers in expanded form, write them in words, and vice versa. And we should be able to graph them on a number line and also use these 2 symbols, which we'll talk about in the lesson. All right, so here are our place values. Now, for those of you that were wondering, not that anyone probably is, but the decimal, if you had one, would go, it always goes to the right of the 1's place value, right? Now, we're not considering decimals yet. In fact, I don't know if we get to decimals in this class, not that it matters. But they're all categorized first by the base units, okay? So you got 1s, 10s, and then hundreds. All the other classifications are based on these values. So right here where it shows thousands, thousands right here, you could identify that as the 1,000s place value. And then it just repeats 1s, 10s, I'll try to use the same color there, 10,000s, and then 100,000s. And that would be all 3 categories in the thousands. And then we move to the millions. Millions, 10 millions, 100 millions. And then billions, billions, 10 billions, 100 billions, and then trillions. We shouldn't see anything really beyond the billions with our calculations or writing words down, but I don't know. I suppose we might. But again, the point I'm trying to make here is that it's all 1,000s, 10,000s, 100,000s. It works that way with all these classifications. 1, 10, 100, 1, 10, 100, 1, 10, 100. Whatever the classification is, okay? And again, we're able, just the way that we use the numbers, to write numbers down, which then represent these place values. I said these are classifications. Some people call them periods. It doesn't matter. So here's a number. That's a big number right there, by the way. So it says write the digit for the given place value in the whole number above. Now, if you need, and you like to use the commas, because on the homework, it doesn't always give you commas, right? So you may want to, you could write it down yourself and then just put the commas in there like this. All right, so this number reads, if I'm looking at it right, 174,182,440,258. So we just need to identify what number, what digit is in each of these specific place values. So first off, we got hundreds, right? So how many hundreds are there? Well, again, to make that determination, all we need to do is find the hundreds place value, and that number will tell us how many hundreds there are. So I start as far to the right as I can go, which is the ones place value. Next would be the tens, and then the third one is the hundreds. And I see a 2 in that place value. So the digit in the hundreds place value is a 2. All right, so that's that first one. Next up, we want to know what digit is in the ones place value. Well, that number is the number farthest to the right, which in this case is the 8. It is in the ones place value, so I put an 8 there. And of course, these would be boxes that you'll be filling in on the homework, all right? Next up, we got billions. So billions, that's pretty far to the left. So let's go through all the place values, okay? Ones, tens, hundreds, and then again, it repeats thousands, millions, and then billions, right? So 1,000, 10,000, 100,000, 1 million, 10 millions, 100 millions, and then finally we reach the billions, and we see a 4 in the billions place value. Now you could write this as 1 billions if you wanted to, but I think on the homework they just wanted it as billions by itself, okay? So yeah, there's a 4 there. Now, were there other 4s? Yeah, there were, but they represent different place values. So only this 4 right here would represent the billions place value. All right, write the digit for the given place value. Same thing as last time. It's just a smaller number, I guess. So this first one, right, we're looking at 10,000's place value. So let's go ahead and find that 10,000's place value. They gave us a comma in the number. And again, I think on some of the homework ones it does, some it doesn't, but this one did. So I have 2 in the ones, 7 in the tens place value, 3 in the hundreds. So that's our base period or category right there. Then I'm in the 1,000s. That's a 1. And then in the 10,000s, that's where the 4 is right there. So the answer to this one, the 4 digit is in the 10,000s place value. Again, that would mean that this number, the 4, tells us there's 40,000 right there. All right, next up, we got the hundreds place value again. So the hundreds place value, that's our third place value, right? Ones, tens, hundreds, that's a 3 right there. So there's 3 hundreds in this number. And then finally, let me erase that garbage. Now we're in the ones place value. Oh, that's a good one. I like it when it's in the ones place value because it's the place value farthest to the right, which in this case is a 2. So I write a 2 in there. There's 2 ones. Now this will lead us straight into expanded form. I guess we're not on expanded form yet, but that's okay. We're doing this backwards, right? So on the past 2 problems, it was like, here's the place value, tell us what digit's in there. Now it's telling us the digit, and we got to figure out what place value it is in. So I would start, we're going to start with the 9, of course, right here. So in this number, I find the 9. Okay, after I found it, then I can go through the place values and make that determination. So the first 3, ones, tens, hundreds, then thousands, right? Thousands, 10,000s, 100,000s, and then finally that 9 must be in the millions place value. So I'll write this in as millions. So yeah, since we're getting started, I should mention this. I know my handwriting isn't always great. I blame it on because I'm a lefty, but some of you guys are lefties and have really good handwriting, which makes me look bad. And I'm okay with that, by the way. But if you can't read what I'm writing on this, please just let me know, and I'll try to make it a little bit better. All right. Let's go to the next number. We got a 3 next, right? There's our 3. So I'm going to find the 3 in this number. Notice there's 9 numbers, and they're all different, right? That's on purpose, I suppose. They are all different? Yeah. Okay, so the 3. There's our 3 right there. In fact, I'll highlight it just so we have that clearly written. So again, I would start with the number farthest to the right. That's in the ones, then the tens, and then the hundreds place value, which means the 3 in the next place value is in the thousands place value. So thousands. Now you may be wondering, well, why do we got to put the S at the end? That'll be important once you start considering decimal type values, because then it's labeled just a little bit differently than this. So if it's just millions, then we know that we're looking at this place value. If it were millionths, then it would be to the right of the decimal place. But we're not worried about that right now, okay? So next up, we got the 8. Okay, so let's go back. I'll try to erase this garbage. All right, so the 8, that's right here. I found it. We just got to figure out its place value. Now, you could take a little shortcut right here and say, well, the 3, I knew that was in the thousands place, which means the 8 just to its left would be the 10,000s place. Okay. Now, you could have started in the beginning too, right? Ones, tens, hundreds, thousands, 10,000s, and achieve the same result, right? So either way works. 10,000s. Boom. Now, just so you understand, the nice thing about the math is that we don't usually have to write this out in words. I mean, we will be, but generally speaking, we don't usually do that just because math people, and you'll learn this pretty quick with my class, math people are pretty lazy, actually, which is why they've developed these ways to write things shorthand. I mean, you think about this too, right? If you're writing this words out all the time, you'd probably want to find a shorter way to write that as well, like 10,000, boom. That's just a place value right there. All right, so expanded form is where we write each of the place values in its value, all right? So like this one, right? This would read 93,146. So you'd say, well, the 9, you could start with the 9, you could start with the 6, doesn't matter, but start on either of the ends. So I'd say the 9, that's in the 10,000s place value, so that'd be 9 10,000s, which is 90,000 there. So we write that out. Then we go to the next place value. 3, that's 3 of the thousands. So it'd be 3 1,000s, 3,000. And we see we're adding these together. Then we see the 1 is in the hundreds place value. That's 1 of the hundreds. So we write plus 100. Then the tens place value is a 4. There's 4 of those tens, which makes 40. So plus 40. And then the 6 ones, just make that plus 6 right there. So that's expanded form of numbers. You're just taking all the digits, writing them out as their place value, and then adding each of the place values separately, right? It almost reads the same way, just you'd have to say plus 3,000, plus 100, plus 40, plus 6, right? 93,146. Boom. Now, there is a little bit more use for this than what we're seeing right now. It becomes a strategy for working with some of the operations, okay? Now, does that mean we're going to be using them? We could. Does it mean it's required? No. It does not mean you have to use any specific strategy. So this one works backwards. It's given us expanded form. What we need to do is change these back into its standard condensed form. So you could say, well, how many place values are we going to need? And you could even give yourself some blanks to work with if you'd like to, and throw in a comma if you'd like. Whether you need that or not doesn't matter, because, you're just typing this number in. So on this one, I got and again, it doesn't matter where you start on either end of this. So, I'll just erase this stuff. So for me, personally, if I were to do this on my own, I'd say I'm going to start with the ones place value, even though I could start with the biggest number on this, okay? Now, why would I start with the ones place value? Because it's the number farthest to the right, okay? So that is the 7, which is in the ones place value. So I would look to the next value in the tens. Tens place value, and that's 10 right there. I'll use a different color. There we go. And there's only one of those tens. So it's not like I'm putting 10 right there, because then it would suddenly read 107, right? So we don't want a 0 between it. I just need how many tens there were, one of them. The next place value is the hundreds, and I see there's 4 of those hundreds, 400 right there. So I put a 4 in the hundreds place value. And then moving to the left still, now we're in the thousands place value, and yeah, we have 2 of those thousands there. So I put a 2 in the thousands place value. So this reads 2,417 in its condensed standard form. Now, one thing I should mention is if you end up with any empty spaces, like let's say there were no hundreds, you'd put a 0 there. Okay, and again, that's the beauty of the number system that we have, is that if there's nothing in there, you can always use a 0 to hold that place value. Like we're not just skipping numbers and just saying we're going to push those numbers together, because in our number system it means something completely different. And then we're going to see that on this one. Now on that one, on that last one, I went from right to left. On this one, I'm going to go from left to right, just to show you that it doesn't matter, okay? So the first number I have here is, well, it's 10,000, right? So 10,000, again, I would still want to probably see the place values out here like this. If I know my biggest number's in the 10,000s place value, then I know I only need 5 place values or blanks that I can fill in, right? So I'd say that the 10,000s, how many of those are there? There's 1. And yeah, this space right here represents the 10,000s. Now we look to the right and we see thousands in this spot, right? But in this expanded form, I don't see any 1,000s. So that's where we use a 0 to hold that place value. And I can continue moving to the right on this. Next would be the 200 in the hundreds place value here. And there's 2 of those hundreds. So I put a 2 there in that place value. Next up is the tens place value here. There's 1 of those 10s right there, so I put a 1. And finally, we end with the ones place value when there's only 4 ones there, so we got a 4 there. Now, I'll say this. I think on the homework, they do not want the commas in there. I mean, if you're doing it by hand, it doesn't matter, of course. But I think on the homework, they do not want the commas. So this one, you just type in, like if you saw this problem, you type 10214, enter, and it would give you full credit. Now, does that mean it will take credit away or it'll mark it wrong if you put a comma? I don't think it will, but I just don't know if it will or not. That's all. Now we have a number, and we're going to write it in expanded form. So, again, start on either of the ends. It just depends on which way you want to go. So, let's say I wanted to start with the 5 in the thousands place value, right? And then we're going to identify the numbers going to the right. So that 5 is in the thousands place value. So I would write that as 5,000. Now the next number, the next place value, I'm going to add to that, right? And we see an 8 is the next number we have. That 8 is in the hundreds place value. So I would have 800 added to that 5,000. But there's more numbers, so I'm going to add even more. Next up is the 1. That's in the tens place value, so there's only 1 10. And then I'll add the final place value, which I have as 7 right there. That's in the ones place value. Sorry, that's a 7. I guess that's a little better. So 5,000 plus 800 plus 10 plus 7 would be 5,817 in expanded form. Now, on this next example, we're going to see a slightly unique situation, although we kind of saw it on that last example. This time, I'll move from right to left on this one, okay? So I'm going to start with the 4 first. And that's in the ones place value, right? So, again, that would go far to the right in expanded form. And then I would add the next place value, which is the 2 in the tens place value. That means there's 2 tens, which is 20. And then I would add the next place value. Now it's showing as a 0 in the hundreds. You do not have to write 3 zeros like that, like there's 0 hundreds right here. In fact, if there's a 0 in any place value, you're just going to skip that place value completely. So don't write it in expanded form. We're going to skip it and go straight to the thousands place value. And there's 9 of those, so that would be 9,000. And then we're going to add the next place value, which is the 10,000s. And there's 3 of those, which would make up 30,000. And that completes that number. We've identified all of the digits and each of their place values with this addition, which makes it expanded form, and we're done. All right, now this is expanded form, but we got to figure out these missing values, right? So on this first one, like we've identified this 10,000s right there, that's the 1. And then we got the 400 right there, that's the 4 in the hundreds place value. And then the 2 in the ones place value right here, right? So in between the hundreds place value and the ones place value, of course, would be the tens place value. So I look at this number and I see a 7 in between the hundreds and the ones place value. Of course, that's the tens place value. There's 7 of those tens, which makes that 70. The next one is a 5. It's between the 10,000s and the 100s. And it's a 5 there in the thousands place value then, so I would write that as 5,000s. Yeah, and again, we should know that the thousands goes there because it's between the hundreds and the 10,000s right there. So again, on the homework, you're going to see problems like this. You just fill in the blanks and then submit the answer. Boom, you got it. Now, this next one, again, we see some uniqueness because of the zeros right there. Again, if you see zeros in any place values, don't write them, which is why we are not seeing those on the right side of this expanded form. Although we do have the 6 for the thousands here. We have the 800,000, which represents the 8 in that number. So we're missing the number between the 100,000s and the 1,000s. That is a 4 right there. Since it's between the thousands and 100,000s, that's 10,000s. There's 4 of them, which makes 40,000. Now again, you can put I think you can put the commas in there, but if you don't on the homework, then I know for sure it will give you the credit for that, okay? So 40,000 right there. Now there's the other blank though, which we missed. That's this 3 right here, right? It's just to the right of the 100,000s. That would make it millions. There's 3 of those, so there's 3 of those millions. So that's, I put some zeros in there. I mean, I know it's 6, but let's say that you put some zeros. I do this from time to time where I either put too many zeros or not enough. So I would want to double check with bigger numbers like this. So I'd say ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, and then I know for sure I've got the right answer. If I had too few zeros, then I would have to add some, of course. If I put too many in, then I would have to start erasing some. So do be careful on these bigger numbers, even like 40,000. Sometimes students would write 2 zeros or 3 zeros, like 4,000. I know they mean 40,000, but they just missed a 0 because they forgot to just double check that stuff. So we need to be able to write the names of these numbers with words. Now, if you're looking at a number written out in words and wrote it out with numbers, you can use numbers or commas rather to separate periods. I was calling them classifications, right? Like if you want to separate thousands from millions, you can use a comma between. If you want to separate millions from billions, comma between those, okay, if you want. But remember, if you're writing these out with words, 2-digit numbers such as 28, tens and ones, no matter what period or classification it's in, it should be hyphenated unless it's in the teens, okay? Or if there's a 0 in, I guess either place value right there, okay? So yeah, like 28 needs to be hyphenated, 42, 73, stuff like that. It should be hyphenated. Now, what we do not want you to do is use the word and. Do not use the word and. Now, it's common for people to, I'll just put out any number, right? I'll try to make that better. 1, 2, 3, 4, 5, 6. That's a 5 and a 6. 5, 6. There we go. In fact, I'll put a 7 in there, right? So a number like this one, it's common for people to use the word and either between the periods or classifications or even between other values, right? Like some people say, that's a 1,234,567, something like that. Now, I didn't mean to make those ands that annoying, but you can see how it could get annoying if you kept using the word and between. That's because mathematically speaking, and of course this is a pure mathematics class, we should only be using the word and with decimal places. Okay, and since we're not dealing with decimals right now, which would be to the right of 7, we don't need to use the word and in between these, okay? So please do not use it. If you do use it on the homework, it will mark it incorrect. So let's write these numbers out in words. First up, we got a 3 and a 4, right? Now, the 3 is in the tens place, the 4 in the ones place. So that would be 3 tens, 4 ones. That's 34. So I'll just put this in 30. But, yeah, don't forget, I kind of went out of that 30. Don't forget to hyphenate this one, right? There's your hyphen 34, okay? So, yeah, don't forget your hyphen for 2-digit numbers like this one. I don't think we're going to need one in this, but for anything like this, 34. And if it would work even if there was something in the 100s place, like 134, still need the hyphen. Even if it's in any of the other place values like thousands or millions and so forth. Now for this next one, I'm going to put commas in there just so we can see a little bit more clearly where the place values are and where the periods separate. So on this one, I see I've got the 1 right here. So that would be 1 million from that right there. Let me see if I can change this a little bit nicer. Yeah, so I got 1 million. Did I miss an L? Yeah, I did. 1 million. Now, again, you don't need to use the word and. In fact, I'm not even going to use a comma because I don't have to. And then I've got a 5 in the 100,000, so that'd be 500. And I know I'm in the thousands, right? So I can just keep it as 100 for now. And then see if there's any other 1,000 place values that are filled in. Now I got a 6 in the tens. I'm sorry, the 6 in the 10,000s place value. So I need to identify that. That'd be 60. But a 0 in the 1,000s place value. Since it's a 0, I don't need to identify it, but I do need to finish this off because I have 560,000, right? So that takes care of the thousands. Now I'm in the base values. Ones, tens, hundreds. And I've got 2 in the hundreds place value, which is just 200. I don't have any tens. That's a 0 in the tens place value, but I got a 6. It's 206, done. Bam. And again, I don't have to hyphenate between hundreds and ones. I would if it was between tens and ones, though, no matter what the period is. So this is 1,560,206. Again, no ands in there because there's no decimals. So standard form, write each digit in its appropriate place value. So standard form, it's going to give us the number in words. We just got to write it out in its actual, standard form. But again, remember, if there's any missing place values, we'll just put a 0 to hold that place value for us. So let's write these two numbers using digits, right? So I got 209,210,305. All right, so I know my biggest place values in, I got 200 million, right? So I'd have ones, tens, hundreds. You can use commas if you'd like. Thousands, 10,000s, 100,000s. Now millions, 10 millions, 100 millions. And that should be enough place values to hold this number, right? So I have how many 100 millions? And again, it doesn't matter if you start with, you can say I'm going to start with the 5 and put it in right there. I know that's in the ones place value, boom. That's fine. If you want to work this way or this way, doesn't matter. I am just moving, starting with our highest place value and then moving to the right. I don't know if I'm doing that just out of habit or if I just thought to do it first. Maybe it's subconscious. I don't care. I suppose you don't either. 200 million to start out with, right? So that's a 2 in the 100 millions place. Now notice it goes straight to 9 million, right? That's in the ones place value, which means there are no 10 millions. So I'm going to have to put a 0 in there. So that takes care of our millions. Next up is the thousands, and I've got 200 of those thousands. So that's the 200 thousands place value, 2 of those. But also 10,000, right? So that's in the 10,000s place value, 1 of those. But there's no 1,000, so I'll just have to fill that in with a 0. And then we're in the base values here. So 300 first, so that's a 3 in the hundreds place value. And notice again, it goes straight to the ones place value, 5 there, which means I need to write in a 0 to hold the tens place value. So that is how I would write 209,210,305. But we'll do the same thing with this next one. Again, it looks like we're going to start with the 100 millions, 300 of those millions, which means I need ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. And how many of those 100 millions are there? 3. But then there's also 92 other millions, right? So that's a 90, that's in the 10 millions, that's 9 of those. There's 2 in the millions, so 2, 392 million right there. Next, we'll move into the thousands. There's only 44 of those thousands, right? Which means it's not identifying any 100,000s, so you have a 0 in the 100,000s. 40 is the tens place value, so that's a 4 there in the tens place value. And then 4 1,000s, so 4 in the regular thousands position. And then again, finish it off with the base units. 310, so 3 in the hundreds place value. 10, that's only 110, so 1 in the tens place value. And of course, again, they're not identifying any ones to put into this slot right here, into this place value. So this would be 392,044,310. And again, see how the zeros apply from the words? It's just that it skipped those place values, which does happen from time to time. All right, I can use these 2 symbols. Now, these 2 symbols, they're very common, but just in case we've forgotten, that is the less than symbol. And if you're wondering, well, why is it less than? I don't really know, but one thing we do know is that this symbol represents these 2 words, which again makes this very shorthand. And if you ever forget, just remember if you write this bad enough, almost like I did, it kind of looks like an L right there, right? L for less than, you could say. And then we have the other symbol there. This one's greater than. Greater than. There we go. And why is it greater than? Because, if you add a little loop right there, it looks like a G. I'm not going to keep that, but whatever. Some people find that clever. I don't know. Okay, but when we look at this in more abstract terms, okay, so as we're saying A and B would be numbers. And it doesn't matter what numbers we're looking at as long as it gives us a true statement, right? So this would read, this right here, these 3 symbols reads A is less than B. Okay, so again, A and B would be numbers like, 1 is less than 2, right? We know that. That would be a true statement. So we need whatever symbols between 2 numbers to make it a true statement. However, it's read. Like if I said A was 3 and B was 1, 3 is less than 1? No, that's a false statement. That would not be true. We shouldn't write that kind of garbage. So think left is less, that's true. This is related to a number line. So on a number line, for now we're starting with 0 farthest to the left, and they get bigger as they go to the right, okay? So they get more positive, we would say. And so you could do this in 5s, you can do it in 10s, whatever. 5, 10, 15, 20, something like this. And any number, like if I put a dot right here, and then a dot right here, the red and purple, I could say that the red is greater than the purple, or that the purple is less than the red because I know the purple is farther to the left, or that the red is farther to the right. So the second set right here, this reads A is greater than B. A is greater than B. This is only true if A is farther to the right on the number line. Up here, this was true if B was farther to the right. Now, yeah, we can go back that far and say, well, it's like an alligator, right? It's going to eat the bigger of the two values. Okay, that's fine. Why does it have to eat the bigger of the two values? Because alligators are super hungry, apparently. Maybe they just eat bacon all the time, which would make sense, like then they're going to eat the biggest amount possible. But, I'm not an alligator, so I can't say with any authority here. So we're just going to fill in these two blanks with either a less than symbol or a greater than symbol, okay? So we would have to consider where these numbers lie on the number line. Now, I usually like to show 0. And I know 1092, I'm not going to put exactly these on or make this proportional by any means. So I would say this is more like 1,000 here. And this one would be, I guess 1,100. Maybe I'd put even another one under 1,200. Now, the reason why I don't need these to be proportional, because I'm just trying to see where these numbers are on a number line, and the numbers farther to the right are bigger than the ones farthest to the left. So 1092 would be, maybe I should use these ones. 1092, maybe around right here. And then 1167 would be about right here, right? So I can see 1167 is farther to the right than the 1092 there. 1092. Therefore, when I put my alligator between these two, I'd have to make it eat the bigger of them, or the one farthest to the right on the number line, which is 1167. And it'll work the same way on this next problem, right? Again, I want to show 0. It'd be very important to show 0 on these number lines if we ever consider negatives, and you will eventually. But I got, let's look at, this is 100, and then I'll put 110 right here, right? So I'd say there's 111. It's just beyond 110 right there. And then 108 is just on the left of that, about right there, I guess, the way I have it drawn. So I see the red, which is 111, is farther to the right than the purple, which is 108. So between this, I would want my alligator to eat the 111. And again, this reads 111 is greater than 108. Or this first one we did, 1092, is less than 1167. Both these are true statements. We need the symbols to represent true statements. And if you're wondering, maybe you think better in terms of money. I mean, I like money, you know what I'm saying? So you'd say, would you want more? Would you want this much or this much money? And hopefully you'd be like, I want both, but we can't do that in this math class, so you can only have one. Okay, well then I'll take this one. Or like this one, I take the 111, boom. All right, graphing on number lines. So they're going to say graph a number on a number line, like this one, 7. Okay, all you're going to do is find 7 on the number line, and you're going to put a dot there. Now, in the homework, you're just going to click on the dot feature, and then you click on the number, and it'll put a dot on there for you. So it's just identifying where the numbers are on the graph. And before you consider this obsolete, we may be using number lines in the future, which may help us to make some calculation. So like this one, identify 1 and 7 on the number line. Okay, let's start with 1. I'll put it in red. Okay, there's 1 right there. So I'm going to put a dot at 1 on this number line there. Boom, that one's done. 7 on the number line, so I find 7. There it is. Put a dot there as well. Boom. That's it. Okay. Don't make that more complicated than it is. Just put a dot where the number is that it asks about, 1 and 7, for example. All right, that concludes our lesson. Just in time, by the way. Make sure you have the 1.1 homework done by Thursday's class, hopefully by Wednesday night, really, because that's the due date. But I'll have that done. The sooner the better. The sooner you get it done, the sooner you don't have to worry about it, okay?